Question 8. Meanwhile, you can have this one. Sorry for the network interruptions. It has costed us, giving the working in terms of segments. Anyway, all shall be well. So you can connect this one with the first session where we had arrived at question 7. Then now question 8 reads, why banking of rods necessary? Why banking of rods necessary? And therefore, we have to consider that one very well. So we can give out several reasons as to why we need to have bagging on our rods. And therefore, the first thing is the friction. The force of friction, or the friction providing centripetal force, centripetal, is not reliable. It's not reliable. Another thing, banking helps in preventing skidding. It prevents skidding. So what is this banking we are talking about? Where we have one part of the rod being raised at an angle. One part of the rod is being raised at an angle. Another thing is that the speed of the vehicle can be increased. We have question. We have now question 9. I give a reason why air is not commonly used as a fluid in a hydraulic lift. We know that air is part of the fluids, which is in gaseous state. And because of the intermolecular distances, air can be one of the key properties of hydraulic fluids is that it should be incompressible. But here, you're having air as a compressible fluid. Say, making it unfit. Making it unfit. Making it unfit. The next question reads, give a reason why, tall buildings are built with lighter materials at the upper parts. Explain. This has to do with stability. So the heavy materials at the bottom will lower the center of gravity, and this brings the building to be very, very stable. So light materials at the upper parts make the building stable. How? Heavier base lowers the COG of the building. Lowers the COG of the building. We can move on to the next question. The figure below shows a swinging pendulum and see it as following. So you are told state the energy conservation taking place as the pendulum moves from A to B and then to C. At A and C, the bodies will be coming to some rest. And therefore, we do expect this one to possess potential energy. This one also to possess potential energy because it comes to some rest. Whereas at B, this is where we expect the body to be moving with maximum velocity. Therefore, this one will possess kinetic energy. So you can say it is potential energy to kinetic energy, then back to potential energy. This is A through B, C. The identical springs of spring constant 3 Newton per centimeter are used to support a load of 30 newtons. Then you are told determine the extension of each spring. Determine the extension of each spring. When you are having such an arrangement, then the first thing you need to check the rule is, do you have to calculate the combined spring constant? Okay, yes. But the first thing, let's convert 300 newtons K for one spring to be 3 newtons per centimeter is equivalent to 300. Then we are told determine the extension on each spring. Determine the extension on each spring. Now we move over. So I'll use the first step where I will say, for this case, since we are having two springs which are in parallel connection, one, I need to look at the combined spring constant. We know that the combined spring constant for springs that are in parallel, then it is N times the spring constant of one spring. Therefore, for our case, it will be 2 times 300, and this will give us 600 Newton per meter. My next step will be evaluate or else giving out the formula of arriving at 600 Newton per meter, which will be the force applied over the total extension AE. So now this will lead us to Kc, which is 600, is equals to a force. From the diagram, you can see we have 30 newtons divided by the E. So our E becomes 30 divided by 600. This is like moving down to 1/20. So our E is equivalent to 0.05 meters. So that will be the extension for each spring in that case. So this one is equivalent to 5 centimeters. 5 centimeters. In a vacuum flask, you are told the walls enclosing the vacuum are silvered on the inside. State the reason for this. You need to mention the reason as to why this is silvered from inside. All this is all about the mechanism of preserving it in a vacuum or flask. So we know that silvered surfaces are poor absorbers and poor emitters of it. So you can say they are silvered to minimize emission of it. Since they are poor emitters. Then we have question 14, which reads, state the features that govern the strength of a spiral of a given material. So this is like asking what are the factors to consider on the strength of a spring. Therefore, we have thickness of the wire, we have the diameter of the coil, still have the length of the material. You are told in question 15, sketch the time graph for a body moving down a viscous fluid. So we know that this body will move with an increase in speed up to a certain level where it comes to move with a constant speed. So here becomes our axis. So here we'll have time, and this one will be velocity. So our time is in seconds. This velocity v in meters per second. So the body will move with an increase in speed up to a certain level. And this is to do with the balancing of the downward forces and the upward forces. So that we may get a certain velocity which is called terminal velocity. We were focused on section 1, section A, sorry, but because of some delays that occurred in section 1, we can touch on question 16 and probably question 17. But more so, let's look at question 16, so that we may have some compensation. Some may read, define the term efficiency as applied. This one is very simple. It is the ratio of work output to work input, and you need to express it in terms of percentage, expressed in percentage. Expressed in. A man used, that is part B, used a wooden plank to lift a log of wood from the ground to a stationary lorry on a flat ground as shown in the figure below. The wooden plank was inclined at an angle of 30. Then you are told indicate on the diagram the direction of the effort and the load. So our effort will be moving in this direction. That is our effort. And our load, since it will be exerting some weight downwards like this, that will be our load. That will be our load. Then our next question, calculate the velocity ratio of the set. The moment you are having inclined planes, we usually get the velocity ratio as 1 over sine theta. So in this case, we are going for 1 over sine 30. And this will lead us to have a velocity ratio as 2. So 1 over sine of theta, then we'll arrive at 2. Calculate the mechanical advantage of the setup if the efficiency is 65%. From the formula that efficiency is given by mechanical advantage over velocity ratio times 100%, then our 65% will be the same as the mechanical advantage we are looking for over 2, then you multiply by 100. So in this case, we shall have, making MA the subject formula, it will be 65 times 2 divided by 100. And this will lead us to 1.3 as our mechanical advantage. Fountain, then you're told determine the minimum power of the pump if it ejects 50 liters of water per minute. Per, per minute. And spray reach to a height of 5 meters. In this case, we can have this one in two ways. One can say that power is given by force times velocity, force times velocity. And in this case, so option one can say power is given by force times velocity. But because we are having distance and time, then you can say force times distance time. So this becomes a force of 50 liters per minute. So we can say this will be from the 50 liters, because we're talking of water, 50 liters is equivalent to 50 kilograms. So if you have to get the force or the weight of this water, then we shall make it mg. So we can say our F here is the same as mg. And I have already given out the kilograms of the water. So now if you say in this part where we are having F to be replaced with mg, then we shall say that power is given by mg d over t, which will be, we have said 50 kilograms times 10 newtons per kg times 5 divided by 1 minute, which is supposed to be 60 seconds. Then in this case, it is going to lead us to a power of 41.37 watts. 41 point, sorry, it's supposed to be 67. 41.67. 41.67 watts. Option 2 or method 2, I'll say that now I need to explain where the 50 kilograms came from. Let me take it slowly. So the mass of ejected water per minute is equivalent to 50 kilograms. Where is this one coming? We know that equivalent to 1,000 cubic meters. So 50 liters will be equivalent to 50,000 meters. And therefore, we know that density of water is equivalent to the mass. The mass will be the same as from density is equals to mass over volume. Logo is trying. Hmm. Mass will be given by density times volume. Then where are we supposed to get the 50 kilograms from? Just a moment. Let me erase this. Where do we get this 50 from? This 50 kilograms is coming from 1 liter is equivalent to 1 kg when it comes to the comparison with the density. Allow me do something over here shortly so that I may have a good way to prove it and to you that it's supposed to be like that. So I've got a way out. So let's use in a simple form where we are talking of, we use this one. I will give an example. Suppose we have 1 liter, which is equivalent to something is not adding up. Okay, 1 liter is equivalent to 1,000 cubic centimeters. So now, from there, we know that density will be 1 gram per kg. So suppose now we ask ourselves these two. So what will be the mass? It is supposed to be density times. So 1 gram per cubic centimeters times 1,000. This will lead us to 1 grams. So in 1 liter, so in 1 liter of, there is 1,000 grams or 1 kilogram. So what about 50 liters? Then this will lead us to of water. So that is where we are supposed to get it. It's simple to use it in terms of density of in the units of grams per cubic centimeters than in this was by the way to know how we are getting 50 kilograms. From here, we can guess flow rates. So it will be it 1 minute, 50 kgs are ejected. 50 divided by 60, so that we get 0.8333 kilograms per cubic. So from here, we need to look at the minimum power. So remember, okay, minimum in terms of mgh, because that will be the energy. So mgh, you divide by T, because we are looking at the power. So at the top we'll have the energy. At the top we'll have the energy. Then the moment you divide by T, then we get the power. So we have a mass of 50 times 10 newtons per kg times a height of 5 divided by 60. So this is the other long way to explain. So these parts, we already have it here. So at long last, we'll still arrive at 41.67 watts. It is a very tricky question that you need to handle it with serious care. And that is why, let me just put it this way. That is why you'll find that because water and honey, they have different densities. That's why the moment a person is selling to you honey, he or she is using a very different can. From what you can imagine, this will be a liter or a kg of water. So do not get worried why that difference is coming from. Give a reason, question Roman 2, why water often returning to the pool has a different temperature from that which left the pump. We have issues to do with the changing of the form of energies, and we also have the exposure to different surfaces. We have the friction with air, air. So I can say, in summary, mechanical energy is converted to heat, that is from the friction in pump and in pipes. We have the viscous dissipation and turbulence. And the other one, we had said that the water will be exposed to different surfaces. So, and because water exchanges it with air. While in flight. So that is something that is very important. I can see somebody by the name Knocklid. He has commented on the live chat. Thank you, sir. Feel welcomed to our channel. Subscribe, like, leave a comment, then share. But before we handle question 17, which I hope will be the last one, question 17, which will be the last one, I'll handle up to part D. So allow me share with you this some goodies. You're having Ascending Grades Online School is thrilled to have you on board for the December holiday program. It is 5 weeks non-stop from 11th of November up to 12th of December, sorry. We shall be having our sciences and mathematics. You can make any inquiry and also enroll through 0757 Back to question 17, you are told define the center of gravity. It is the point of application in an object where all resultant forces act. Where all the resultant forces act. We have part B. We are being given a wine glass as shown in the figure. Then you are told, explain how the stability of the glass is affected if it is filled with wine. If you add any liquid, no matter if it is wine or something else, if you add a liquid inside here, then we shall be raising the COG. So the moment the COG is raised, what do we expect? We expect to lower the stability. So the stability of this wine glass decreases. So you can say the glass becomes unstable. Why? The filled wine raise the COG. It raises the COG. It raises the COG. Then now we have C. In a triangular ABC shown in the figure below, determine geometrically the center of gravity. So in this case, you are supposed to bisect any two sides. You bisect any two sides. And maybe in this case, mine may not be accurate because bisecting you need to have some high levels of accuracy, because I do not have the apparatus to do that job. Then I'll use demonstration. So suppose now I'm picking point AC from my screen or from where I'm measuring from. This one is giving me 5.5, or you can call it 5.6. So the moment I'll be bisecting, then it becomes 2.6. 2.3. Sorry, 2.8. So 2.8. So I'll bisect here. Like that. Then I move to the next one, which is suppose I pick AB, or whichever the case. If I pick CB, so if I pick CB like this, then I bisect again like that. Then this point where these two bisecting lines meet, this becomes my COG. That becomes my COG. So even if we bisect AB, it will still lead us to the common pole or the common point. May I have the last part, which I'm going to talk tonight? The figure below shows a uniform rod AE, which is 40 centimeters long. It has a mass of 2 kg pivoted at D. If 2 Newton is acting at point E and 30 Newtons force is passed through a frictionless pulley, then you are told, let me write the question. Then you are told, find the force X acting at end A. So you are supposed to find our force X. So now we need to solve this one. And how do we go about it? The first thing is we need to establish where the weight will be acting. So at the center of it, we expect to have the weight. So at the center, we expect to have the weight. And since it is of mass 2 kg, it will be 2 times 10. So this one is equivalent to 20 newtons is acting at the center. And which is the center? The center is at 20 centimeter mark, because the total length here is 40. The total length here is 40. So from here up to the pivots, we expect to have a distance of 10 centimeters. Like that. And since this one is also the halfway, and on this side we are having 10, so 10 plus 10, then we'll get the remaining 10. So now we say clockwise moments is equals to anti-clockwise moments. Let me change the trace. So the clockwise moments is equals to anti-clockwise moments at an equilibrium. So in an exam, write the full meaning. So you say clockwise moments equals to anti-clockwise moments at an equilibrium. So now, if you look at this one, you need to understand which forces are contributing to clockwise moments. Number one, we have the 2 newtons. This one is contributing to clockwise moments. And then the moment this one moves up, because the 30 newtons is pulling downwards in this side, but in the reality, it is pushing the rod upwards. So 2 newtons and 30 newtons combined, they are trying to push this rod in the clockwise direction. So we'll say 2 newtons times this one. The perpendicular distance from the pivot here is 10 centimeters, which is equivalent to 0.1, plus the second force, which is 30 times what will be the perpendicular distance. So from here all the way to the pivot here, it will be 10 plus another 10. This comes to be 20 centimeters, which is equivalent to 0.2 centimeters. And this one is equivalent to the anti-clockwise moments, which is of force X and 30, sorry, force X and the weight. So we start with the part with the weight. So from the pivot up to where the weight is acting, we have 10 centimeters. So it is 20 times 0.1 unit close, then plus the 20 newtons, which is the weight, times, sorry, it's supposed to be the now the X, this one, X times the perpendicular distance. How many tens can you see? We have 1, 2, 3. So 10 times 3 is equivalent to 0.3 meters. So times 0.3 meters. So now this one is 6 is equals to 20 times 0.1. It becomes 2, 3 x plus 0.3 x. Okay, so we make 0.3 x to be the subject of the formula. So we group the like terms together. So 0.2 minus these 2 is equivalent to 0.3 x. So our x is equivalent to divided by 0.3 to I can see somewhere we have missed somewhere here. Which is that part? Okay, if we calculate, then it becomes 4.2 divided by 0.3. We get 14 newtons, like that. Thank you so much for tuning in. We are very sorry for the inconveniences. The title of the working will be researched afterwards, immediately after the end of this session. But before then, welcome to Ascending Grades. We are thrilled to have you for the December holiday program. Enroll your child for a 5-week online session from 11 up to 12th December. The number is on your screen. Trust us, and then we're gonna help you keep your son or daughter engaged and expect positive trajectory of the resource. Elevate your grades, elevate your future. Goodbye. Thank you.